When it comes to combines, farmers around the country will agree that the bottom line is productivity.
Productivity, simplicity, I'd say, in design and maintenance. Something that can go out day in and day out and work without any problems.
Grain quality is very important, and that was one thing with the 915. It was a good machine, but it was limited to your quality. And when I went to the 1460, it improved dramatically. And basically, you can get your FM right down to very little. And that's what the elevator wants, and that's what I want, because there's no dock.
When I had a conventional combine, I used to clean all my grain with a screener before I run it into my drying system, because the additional fines in the bin drying system that I had would cause me some problems as far as drying. Since I bought the Axial Flow, I haven't used the grain cleaner.
Hello, I'm Tom Kramer for CaseIH. It's true what customers say about combines. Productivity is key. So let's briefly look at what customers expect in a combine. First, they expect high grain quality. That is, whole, undamaged grain. Second, they rely upon grain saving capability. How grain is deposited in the tank rather than on the ground. Next, customers depend upon simplicity, meaning ease of operation and service. Finally, they require adaptability to a variety of crops and conditions. Over the past decade, CaseIH has consistently met these customer expectations, refining our Axial Flow combine design, making it the state-of-the-art combine we offer today. John Deere introduced their 9000 series conventional combines to compete directly with the CaseIH Axial Flow. In this program, we'll examine these two combines, how they're alike and how they're different. Deere has implied that the 9000 series is a technologically advanced machine. We'll identify what on the Deere is really new to the industry and what isn't. In many aspects, Deere's changes still do not measure up to the Axial Flow. Most important, we'll discover how each combine design affects that bottom line, productivity. For starters, let's talk about threshing design philosophies. For years, CaseIH has produced the Axial Flow single rotor concept, a proven threshing and separating design. With one moving part that performs threshing and separating, CaseIH has eliminated many of the parts which are necessary on a conventional combine. Grain harvested by an Axial Flow combine enters the rotor with less impact than conventional cylinder models. The impeller blades rotating within the transition cone accelerate the crop to threshing speed prior to impact with the rasp bar and concave. This design also smooths out the crop mat for uniform threshing and separating. Inside the rotor cage, the grain has several opportunities to be threshed and separated. Working with centrifugal force, the Axial Flow easily separates grain from the straw without complex straw walkers, which depend upon gravity to do the job. Centrifugal force provided by the rotor is up to 40 times greater than gravity, and therefore more efficient for separation. Threshed and separated grain passes through the concaves and grates. Then it's delivered to the adjustable cleaning system prior to delivery into the grain tank. Finally, straw is delivered by the discharge beater back to the straw spreaders at the rear. The result of all this technology? Less damage to the grain and more grain saved. John Deere's 9000 series, on the other hand, has stayed with a conventional cylinder straw walker design. Again, you can see the difference in the John Deere philosophy as compared to CaseIH. The grain first contacts the cylinder, which severely rubs it against a concave to thresh and separate. Since this system allows only one chance for threshing to occur, it's subjected to rough handling of the grain at the cylinder. In this one-pass system, there's a greater chance for grain damage. Grain that is not threshed from the straw on this one pass may be returned for rethreshing where grain damage can occur, or it may be lost out of the machine. Conventional cylinder designs such as Deere's tend to impact the grain severely. thus contributing to grain damage. Deere increased cylinder diameter and concave wrap on threshing components. This was presumably done to increase throughput capacity. With increased diameter, it's necessary to reduce cylinder operating speeds to maintain the correct rasp bar tip speed for threshing. Deere states that their reduced cylinder speed will reduce grain damage. Our tests on conventional cylinders show that grain damage is a result of tip speed, not solely cylinder speed. With almost the same tip speed as their previous models, it's difficult to understand how grain damage could be reduced. The Deere cleaning system has several changes. The most notable of these is a pre-cleaner sieve. Deere states that this pre-cleaner sieve improves the overall efficiency of the cleaning system. Yet their operator's manual clearly states that it should be kept fully closed in all crops except corn and popcorn. Finally, at the rear of the combine, Deere separates grain from straw by using traditional pitch and throw action straw walkers, relying on gravity to complete the final separation. The inefficiencies of straw walkers in high throughputs or with damp straw or husks is a major source of unacceptable grain loss. In order to control these losses, Deere lengthened the straw walkers on the 9000 series. Now, these are two very different approaches to threshing and separating, but only the axial flow rotary system consistently satisfies the customer's needs for high-quality grain and crop-saving capability.
We had to be careful with that conventional machine and with grain quality. With this, you set it and pretty well run the harvest, and you've got an excellent quality, no docked elevator, which you're going to get a bigger check. That's just all there's to it. It's just, you're going to get fully paid for high-quality grain.
When we used to raise some seed beans for a seed company, and they were always happy to have the actual flow combine. You know, our premiums, we could get 60 to 70 cents a bushel more just with because of the actual flow combine. They could tell when we come in with beans, the people there could tell which beans were combined with a conventional compared to an actual flow.
Combine weight and overall dimension should also be considered. There are some notable differences. The chassis length of the John Deere exceeds the CaseIH combine by as much as 5 feet on the larger models and by almost 4 feet on the smaller machines. Combine height is also a factor. The John Deere is at least 1.5 feet higher on all combine models. With some disassembly, their transport height can be reduced, but this still leaves them taller. These differences can be graphically compared by superimposing one combine over the other. As you can see, the Axial Flow combine is more compact than the John Deere. So what does this mean to customers? Well, dimensions, including shipping width, play a part in the total maneuverability of equipment, especially in transport and storage, as well as turning at the end of the field. Turning radius on the Deere 9000 series is considerably greater than the more compact Axial Flow. Where weight is concerned, the John Deere combines outweigh their CaseIH counterparts in every class from 2.5 to 3 tons. This additional weight can affect actual field operation. Additional weight takes more power, increases the opportunity to get stuck, and increases soil compaction, which has a negative effect on future yields. Now let's take a look at serviceability. This year, Deere boasts 50% easier servicing and 33% fewer belts and chains than their old Titan II combine. But these changes are not really new to the industry. John Deere decreased their number of belts and drives, but what about the accessibility to service them? CaseIH, on the other hand, has a minimal number of belts on each drive, and the belt tighteners are spring-loaded, requiring fewer adjustments and extending life. What about those belts and chains Deere removed? Well, this year, Deere introduced a beltless hydrostatic drive system. Like CaseIH, they have recognized the reliability and low maintenance of this beltless direct drive, which we introduced in the mid-60s. Over 10 years ago, CaseIH recognized the advantages of placing the engine to the rear of the combine, easy maintenance, a quieter cab, and better overall weight distribution. John Deere has followed suit, mounting their engine to the rear of the combine. But while they made the change to the rear, Deere failed to consider one important need: accessibility. Engine service requires many more swing-out shields to access than on the axial flow. And the front of the Deere engine is only accessible through the grain tank. In contrast, the engine on the CaseIH axial flow is readily accessible from either side. The axial flow's rear service deck puts you right at the engine. The deck also lends to easy access of the hydraulic fluid reservoir, fuel tank, and air cleaner. When we compare service accessibility, the CaseIH combine is far more convenient and more accommodating. Finally, consider inspection of the concave and great auger bed areas on the axial flow compared to the new Deere line. Everything is much more accessible. Overall, the service advantages of the CaseIH axial flow combine outdistance the John Deere in terms of simplicity and ease of maintenance. Again, CaseIH addresses the productivity factor head-on.
The simplicity of the machine. Our 915 had a lot of belts, a lot of chains, straw walker problems. The actual flow, we looked at that, very few belts, very few chains, and we really liked that. And over the years that we've had them, it's really been a time saver for us as far as any maintenance that we've had with it. Very few things go wrong.
Serviceability on the axial flow combine, I found when I went from the 915 to the 1460 was a great change. It was very easy to work on them, make any changes. Everything's very accessible, and you don't have to service them very much. It doesn't take much to grease them. There's not much fixing on them. They just run.
The first one we had a lot of hours on it when we traded it off, and it only cost about 50 cents an acre for repairs on it. It was just great.
Now we'll focus on the feeder house. There is a big difference between the two feeder reversers. The Deere system requires keeping the combine separator running in order to activate their feeder reverser. In a situation where everything is slugged, the reverser cannot be used until the cylinder drive is disengaged. The operator must get out of the cab, walk all the way around the combine or header, and pull the pin on the cylinder drive. The CaseIH reverser can be activated with the separator on or off. If the axial flow feeder or header becomes slugged, the operator can easily reverse the feeder house from the operator's seat. Deere's header hydraulics and electronics require the operator to make hookups on both sides of the feeder. On the axial flow, all electrical and hydraulic hookups are quick and easy, all completed on the left side of the header. Another point of comparison on these two combine designs is the cab area. Deere has finally acknowledged what CaseIH has known since the beginning, that for maximum header visibility and optimum control of the combine, the cab should be centered over the feeder housing. The entry to both combines is easy, except in muddy conditions. Due to its pivot forward design, Deere's bottom step must be removed in muddy conditions, forcing an uncomfortable reach. The operator's ladder on the axial flow combine pivots up and out of the way. Both cabs feature the same basic engine and shaft speed monitors. The Deere's shaft speed monitor checks 6 shaft speeds plus the engine RPM. CaseIH monitors 9 shaft speeds, and engine overload is part of the digital TAC. CaseIH recognized the operator convenience and reliability of electro-hydraulic controls in 1981. Now Deere has electro-hydraulic controls. Lighting on the CaseIH combine goes beyond what Deere provides. The headlights on the axial flow are completely adjustable, while the Deere has a limited adjustment range. The CaseIH cab has a convenient right-hand window that opens. It allows for easy communication with other people. Deere's right-hand cab window does not open. The standard seat in the 9000 series Maximizer is a solid mount with no suspension. The CaseIH axial flow features a standard mechanical suspension seat with an air suspension seat offered as an option. These cab features meet the customer's needs for comfort and convenience. And again, Case IH comes out on top. Now let's look at some factors that contribute to combine adaptability to different crops and conditions. First, concaves. The Case IH Axial Flow Combine has concaves which can be changed by one man in less than 30 minutes. They're accessible and they offer crop versatility. Small and large wire concaves are available to suit the particular crop. Deere has added a small grain concave in order to make their combine more efficient in small grain. Yet, changing Deere's concave appears to be a difficult and time-consuming operation compared to the axial flow. Also, Deere concaves require daily maintenance and adjustment to prevent crop buildup. Next, cylinder speed flexibility is another factor. The Case IH combine has a dual-range rotor drive as standard equipment on all combines. Using a push-pull lever, high or low range is easily selected. Deere boasts about the flexibility of their dual-range cylinder drive, but to change speeds requires the removal of pins, an adjustment and rotation of sheaves. Compare the cost and time involved in fine-tuning the Deere combine as opposed to the simple versatility of the Case IH. Deere no longer offers optional straw walkers. The Axial Flow offers 3 different separating grates to accommodate different crops and conditions. The owner can easily adapt their Axial Flow in order to receive the performance they desire. Case IH customers know that for adaptability and flexibility, the Axial Flow is most efficient.
Any adjustments that we do when we move from corn to beans, we, within about a 5-minute period, we can be switched from corn to beans. Very simple. That's one thing we like about it, is that when we start, we may do corn in the morning, switch to beans in the afternoon, and like I say, within 5 minutes, we're back going on the beans that afternoon.
Yes, the change of the grates, I would say a half an hour to change the grates. That's just in my mind, and I've done it enough to know what I'm talking about.
At Case IH, we're committed to producing the finest harvesting equipment on the market today. Our customers have come to expect only top quality performance and productivity from our combines. The Axial Flow Combine has a bright future, as noted in a report by the investment firm of Smith Barney, because the rotary combine's separation process is gentler, thereby producing more efficient, better quality grain. The rotary business is expected to overshadow conventionals. The fact remains that Deere chose to stay with conventional design technology. Many of the improvements in their 9000 series combines were features originally introduced on the Axial Flow. Simply put, the rotary design threshing system is state-of-the-art, making Case IH the industry leader in harvesting equipment.
I've more than once went to an elevator and have a positive comment that they're pleased to have anybody bring in grain out of an international Axial Flow combine because it's high quality. It's just #1. That's the truth. There's nothing stretched about it.
I, investigated quite a bit. In fact, I had even went and talked to the Deere people. Well, when are you going to come out with a rotor? We're not going to. And that's when I decided I'd go to somebody that had one.